Hi friends, today we have to discuss an interesting and wonderful concepts. The last class we have already completed how to find the derivative of composition function by using the chain rules. Today we will discuss details how to find the derivative of an implicit functions. Hence, implicit functions. Right. So to start with this concept, I have two examples in front of you. Here we will discuss what exactly the implicit functions. So first equation is y is equal to 2x plus 3 and second equation x plus sin xy minus y is equal to 0. In the first case you see it is expressed y is equal to f of x. Here x is independent and y is dependent on x. So here y is isolated in one side of the equations. Here dependent variable is isolated in one side of the equation. One side of the equations. Similarly, you can also express x in terms of y. How I will change it? You see that y is equal to 2x plus 3. You can write also x is equal to y minus 3 by 2. You can take another function also. Here you see y is independent and x is dependent. Here also dependent variable is isolated in one side of the equations. So this type of equation is called as the explicit equations. It's the explicit equations. So this type of equation is called as the explicit equation. It's called as explicit equation. Coming to the second one, इसमें you see, so y is equal to that x plus sin xy. Y is equal to x plus sin xy. Look at these equations. Can you isolate y in one side of the equation? No, it's not possible. You cannot isolate y in terms of or one side of the equations. Here y is expressed in terms of y or x is not possible for these equations. So here it is not possible to what happened to isolate y in one side of the equations. So this type of equation is called as implicit functions. So you see now definition, a function f of xy is said to be an implicit function if It is not ever possible. It is not possible to express y in terms of x or vice versa. What does it indicates? Express y in terms of x or x in terms of y. It is not possible in case of the implicit functions. For the implicit functions, right? So next what will happen? So in this case, how to find the derivative of this implicit functions? How to find the derivative of the implicit functions? Let us take, for the above questions, we have taken x plus sin xy. That x plus sin xy minus y is equal to 0. So how to find the derivative of y with respect to x? How to find the y with respect to x? To find dy upon dx. How to find it? One thing you do, now differentiating this entire equation with respect to x. Differentiating the above equation in terms of x. Differentiating y in terms of the x. We get x plus sin xy minus y derivative of this. Clear? And you know, the derivative of a sum is equal to sum of the derivatives, and derivative of the difference also difference of that derivative. If you apply that property, you can have dx upon dx, derivative of sin xy with respect to x, derivative of y with respect to x, and derivative of a constant 0 is a constant, that gives you 0. And you see, if you apply the chain rule here, dx upon dx, you know that is 1. Here, this xy sin xy, but you see with respect to x is given. In this case, what you will do? Derivative of sin xy with respect to xy into derivative of xy with respect to x minus dy by dx is equal to 0. Up to clear? Okay. So 1 plus then derivative of sin theta with respect to theta. You know, derivative of sin theta with respect to theta will have the cos theta. So applying this concept here, you will have the cos of xy into derivative of x into y. Apply the product rule. Derivative of uv, that u dv plus v du. So x into derivative of y with respect to x plus y into derivative of x with respect to x minus dy by dx is equal to 0. Next you see 1 plus cos xy, that x into dy by dx plus again y into cos xy, because dx upon dx, that is 1, minus dy by dx is equal to 0. Next, there are two places you are getting dy by dx. Now write side by side that x cos xy dy upon dx minus dy by dx, and take the other terms to the right hand sides. The minus 1 minus y cos xy. Here you can take common dy by dx. You have x cos x into y minus 1, and this will be minus of, if you take 1 minus 1 common, you have 1 plus y cos xy. Then this dy by dx, because x cos xy minus 1 is multiplied in the left hand side, when it carried to the right hand side it will be divided. So 1 plus y cos xy by x cos xy minus 1. Right? This is our required answers. This is our required answer. Similarly, if you take another questions, same type questions. Okay, looking at the second questions, suppose question is given sin square y plus cos xy is equal to pi. To find dy upon dx. Before going to find out the derivative of these equations, first of all see what is the meaning of sin square y. You know, the sin square y means the square of sin y. First of all, you must be clear about this one. Then what will you do? You will apply the same concept, differentiating both sides with respect to x. Differentiating the above equation with respect to x, we get sin square y plus cos xy derivative of pi with respect to x. So now derivative of the sum is equal to sum of their derivative. So derivative of sin square y plus derivative of cos xy with respect to x, and derivative of pi you know 0. Since derivative of a constant with respect to 0 for k belongs to r, where k is a constant. Now I have told earlier, you see what is the meaning of sin square y, means derivative of sin y whole square. One square is given by applying the chain rule, you must have write with respect to y, again derivative of sin y with respect to what? With respect to y into derivative of y with respect to x. This is by applying chain rule. We have discussed earlier how to find the derivative of function by using the chain rule. Again also derivative of cos xy with respect to xy into derivative of xy with respect to x, that is equal to 0. I think this line is clear to you. Here what I have done, only the chain rule. Here I have applied the chain rule, here also apply the chain rule. Which formula will be applied here? Derivative of x to the power n with respect to x, you have n into x to the power n minus 1. Or next formula will be used, derivative of sin theta with respect to theta, that also gives you cos theta. Another formula will be used, derivative of cos theta with respect to theta, you will get the minus sin theta. And here also at the end you will use derivative of the product, u dv plus b du. This formula will be applied in this line. So you see the first one, the derivative of sin square y with respect to sin y. You will have 2 into sin y. Next, derivative of sin y is equal to cos y into dy by dx. Plus, coming to the second term, derivative of cos xy with respect to xy. You can apply this formula cos theta. So minus sine of xy into derivative of xy, apply the product rule. That x dy by dx plus y dx upon dx equal to 0. Then apply the same concept. 2 sin y into cos y, that is your sin 2y minus sin xy into x, here dy by dx. Sin 2y dy by dx minus sin xy x dy by dx minus y sin xy dx upon dx, that is equal to 1, is equal to 0. So in these two terms, you can take common dy by dx. You'll have sin 2y minus x sin xy is equal to y sin xy. So dy by dx is equal to y sin xy divided by sin 2y minus x sin xy. This is your answer. Check it. Right? It's not a difficult task. It's very simple. But while answering this type of question, and the basic formula should be in your minds, then you will be succeeded. Okay, looking to the next questions. Very simple question. X square plus xy plus y square is equal to 100. Find out the derivative of y with respect to x. Same principle applied, differentiating both sides with respect to x. X square plus xy plus y square, again derivative of 100. Since 100 is a constant, so derivative of the constant 0. Next, applying the operation of the derivatives, derivative of the sum is equal to sum of their derivatives. So like this, derivative of x square with respect to x, derivative of x into y with respect to x, derivative of y square with respect to x, that is equal to 0. Like this you can get it 2x plus, is the product rule you can apply, x into dy by upon dx plus y dx upon dx. Here you can apply the chain rule, derivative of y square with respect to y, the derivative of y with respect to x, that gives you 0. So 2x plus x dy by dx plus y plus 2y dy by dx is equal to 0. Here in this expression, in two places you have dy by dx. You can take common from these terms. You have x plus 2y, and the remaining terms take to the right hand sides. Minus of y plus 2x, then dy by dx is equal to minus y plus 2x upon x plus 2y. This is your required result. Right? Any problem with it? So like this you can find out the derivative of the implicit function. Okay, thank you.